Hi, everybody. My name is Joy Ting, and I'm the research enologist for the Winemakers Research Exchange. Welcome to the first in a series of 20-minute takeaway videos. The idea behind these videos is to highlight results from projects for which there's not much to taste, so we don't see them at sensory sessions, but from which there still is a lot to learn. I'm joined today by Rick Tagg from Delaplane Cellars. Hi, Rick.
Hi, Joy.
We're going to be talking about a project that Rick did, testing the accuracy and precision of juice analysis at local service labs. So Rick, to get us started, tell us a little bit about why you wanted to do this project.
Well, I was sending all my samples, my juice samples, to a lab. And the bottom line is I started getting really inconsistent results in the bricks compared to what I was doing with both a hydrometer and a refractometer. And then I started looking at the results more closely and realizing that the Yan samples didn't seem right, but I had no way to base any kind of conclusion on that because I just had the one sample, but they just didn't seem right. So I called you to ask you how to interpret those results.
Yeah. So
right.
I got this call from Rick, and he was like, how do I know whether I can trust the service lab? How do I know what to do with these numbers? And that's when we sort of cooked up this idea to essentially be secret shoppers of our local service labs. So I'm going to go ahead and share my screen, and we'll show you what happened with that experiment. Let's see. There we go. Okay. Can you see, Rick? Can you see the slide?
I can.
Okay, excellent. So the way that we set up this experiment is we sent 3 replicate juice samples to 4 different labs. So Rick had a tank of Chardonnay juice. After it was cold settled and racked, we took 12 tubes of the same juice, and we sent 3 of each of those tubes. Before we sent them, we did freeze the juice. The reason we froze the juice is to make sure that we had comparable samples to going to each one of our labs. I will say, though, if you ever have the opportunity to get your lab testing done on fresh juice, it probably will give you more accurate results or more reliable results than using frozen juice. And we'll see an example of why that is in just a moment. Once our tubes were frozen, they were shipped overnight in cold packs in insulated packs with little cold packs stuck in there. We shipped them overnight to ETS, which most of us kind of think of as the gold standard in lab testing, and then 3 different Virginia service labs. For each one of these, we are going to be reporting Brix pH, TA, malic acid, and Yan. I'll look today in our video, we'll look at Brix pH and Yan. If you want to know the numbers for TA and malic acid, those are included in the report that will sort of be posted along with this video. Before we jump into the results, though, I did want to define our terms just a little bit. We said that the study itself was looking at the precision and accuracy of these different tests. So when we talk about accuracy, we're talking about how close the measurement is to the true or accepted value. That's important to us as winemakers because we want to know what the actual Brix is so we can make decisions, for example, about chaptalization. We want to know what the actual acid is so we can decide if we need to acidulate it, how much. But we're also interested in precision, and that's how close multiple measurements of the same thing are to one another. That matters for us too, because oftentimes we're not sending multiple samples of the same thing, we're just sending one sample. So we need our results to be both accurate and precise. These concepts are shown pretty well, I think, in this little graphic. Graphic A shows us an example of a dart thrower that is neither precise nor accurate. The darts are all over the place and they're not anywhere near the target. B shows us an example of one that's precise but not accurate. So the dart thrower is throwing in the same place every time. Unfortunately, that place is not the target we're looking for. C, it turns out, is accurate as a group, but not precise at all. If we average out all 4 darts, we get right on target. Unfortunately, none of the darts themselves are hitting the target. D gives us an example of what we're really looking for in our lab analysis. We want something that no matter if we only send one sample, we still get a good, accurate result. The other thing we want to think about as we're going through the data are what might be the sources of error in the results that we get back. So some of these we can do something about, some of them we can't. So one of those is sample collection. In our experiment, we took the juice right after it was cold settled, before it was inoculated. And that's really a good way of taking samples for white juice analysis, because that's what the thing that's closest to what your yeast are actually going to encounter. With your red juice samples, the same principle applies. You want to take your sample right before you inoculate, as a way of saying, this is the best representation that I can come up with of what the yeast are going to have available to them during fermentation. Another source of error, though, is shipping. And we've already touched on this a little bit. When we ship our samples, juice samples are really unstable during shipping. They can start to re-ferment along the way, and that significantly changes the different metrics that we're looking at. This is pretty different between juice and wine. When we're sending wine samples, the wine itself is often pretty stable, and it doesn't change as much during shipping. But for juice, that's a consideration for sure. Another source of error is just inherent in the testing procedures themselves. No matter how well the test has been developed, every testing procedure has a limit of accuracy, and it has some known error along the way. The tests that are used by our service labs are ones that have been developed to be as close as possible. But again, every test does have some inherent error along the way. And then, of course, there's human error, right? No matter who's doing the test, we're all humans, and we all kind of have a bad day with a pH meter once in a while. Our service lab technicians have lots of things in place in order to try to make sure they can understand if they're getting an aberrant number. But again, human error is definitely there. Okay, so with that, let's go ahead and jump into the results. So the first result we'll look at is the Brix. And so this is one that Rick identified. The first thing he noticed in his lab results that kind of didn't match his own was the Brix number. So when we look at the graph here, I've plotted each of the 3 replicates for each of the 4 labs. So the labs are along the x-axis, and then the replicates are going, there's 3 replicates for each of those labs. There was nothing special about which replicate was which, that was just randomly assigned. And again, these were all the same juice, so they should all look the same. So the first thing you notice here is that I should also say ETS is always lab number 1. So even at ETS, there's a span of Brix numbers. And that span is not small. The ETS gave us numbers between 19 and 19.9. So if our gold standard lab is giving us the span of Brix number, what is going on? I think the best guess I have here is probably our replicate number 2 maybe started to thaw and maybe started to ferment in the tube as it was going along. And that way, and by the time it got red, it was a lower number. Most likely that's also probably what happened with lab number 4 in replicate tube number 2. Now, again, if we're only sending 1 tube, we don't know that this is what's happening. So this is why I always recommend that you have a really good way of measuring Brix in-house. Most of us can do this easily. Most of us know how to do this. But I would say that it's always useful to look back at the published protocol for the type of test you're doing, and just make sure that you're calibrating your refractometer correctly, that you're doing your temperature corrections, and that everything is cleaned well enough that you can trust your in-house number for this. Because again, that re-fermentation or that fermentation in the tube can cause a problem with the number. The next set of data that we'll look at is the pH. So if we look at all of these, the first thing you might notice is it looks like for labs 1, 2, and 3, we didn't get all 3 of our replicates back. If you look at the data on the table, though, you can see that we did get them all back. They're just plotting right on top of each other. This is a measurement that comes back very precisely. The lab seems to get the same number each time. However, we can also see that our labs 2, 3, and 4 have notably higher values for pH than what lab 1 has. Lab 1 is in the 3.5, it averages out at 3.57, whereas the other labs are all above 3.7. That's a big difference when it comes to decision making. When I saw this result, again, lab 1 is ETS, whereas labs 2, 3, and 4 are our local service labs. So I called ETS and I said, is there something that you're doing here that can account for this? And what Rich from ETS told me is he said, whenever we know that we have a frozen sample we know that when we're freezing the sample, we're essentially cold stabilizing the juice, and we're taking some of the tartaric acid out as potassium bitartrate. So to correct for that at ETS, they'll thaw the sample on the bench top, and then after the sample gets thawed, they'll briefly microwave it in order to melt that potassium bitartrate back into solution to account for that change. So that would sort of give us the result that we see here, that we have a notably lower number for our pH than we do at our local service labs. Now, normally, if you're using a local service labs, you're not actually having to freeze that sample. So hopefully this isn't a problem that would happen if you're able to get a fresh juice sample to your service lab. But if you do have to send frozen samples, for example, it's over the weekend or something like that, it's important to keep in mind that that difference might be occurring. And this gets back to the other thing that I just said about bricks. One way around this is to make sure that you have a good, reliable way of measuring pH in-house. This is, again, pH is something that we can set up pretty inexpensively, and it's a pretty easy test to run if you know how to run it. I will say, if you're running your pHs in-house, you do again need to make sure that you're calibrating correctly, that you're running standards, and making sure to maintain your instrument to make sure that you get a good, reliable number. Now, most of us are not actually sending out for bricks or pH. We're really sending out, as Rick said, for our YAN numbers. So these are the YAN numbers that we got back from our different service labs. Now, in this case, if we look at our overall averages, or the overall span here, this is kind of a big span of numbers. You know, we go somewhere from, like, what I think the lowest one is 177. The highest one looks like it's about 230. And even if we look at the averages there, lab 2, the average for lab 2 is 180. The average for lab 1 is 224. If we go by kind of our yeast manufacturer recommendations, we might be making different decisions in terms of feeding the fermentation, depending on which of these labs we send our samples to. We can also see that within the lab, we do have some span as well. So again, thinking about sources of error, what might be happening there. The first thing, again, if we look at labs 1 and 4, we notice once again, it's replicate 2 that has a lower number that's causing a little bit lack of precision there. If we think that the juice started to ferment in the tube on the way, giving us the lower bricks that we had, the first thing that's happening with those yeast is they start to gobble up some of that nitrogen. So we would also expect the nitrogen to be lower. Unfortunately, if we're only sending one sample, we don't know that. We don't know that that's happened in the tube, and we might get an incorrect number that way. But the other thing to think about with YANs is that each one of these labs is using a different technique for measuring YANs. Some of them are HPLC methods, some of them are enzymatic methods, some of them are FTIR methods. And those different methods might be measuring those YANs a little bit different and sort of always giving us a lower number. So the next kind of question would be, if we were to do this again, would we consistently get lower numbers, for example, from lab 2 than from the other labs, based just on their methodology? So if we take all this together, kind of what can we take away from this? What could we say? What can I say to Rick to answer this question that he called me about last year? A couple of things. The first thing I've already said is, whenever possible, measure things in-house on fresh juice with well-calibrated instruments as much as you can. I realize most people don't have the capacity to have a spectrophotometer and do YANs in-house, but you can do bricks and pH, especially, and sometimes TA in-house, as long as you make sure to calibrate things and keep them clean. I would highly recommend that you do have some standard outside of your calibration buffers in order to know that you're on the right track. So for example, for pH, you can send a sample of box wine, which tends to be really stable, to one of your service labs, get a number for pH and TA and anything else that you might be measuring, and keep that number. And then once you calibrate your pH meter, go back to that number as a standard. Another good standard would be using cream of tartar. So the same thing that you use to seed cold stability in the tank. If you do a super saturated solution of cream of tartar, that always comes out at about 3.55 or 3.56. It's always good to be able to run these standards to know if your pH meter runs high or low or something like that. If you do need protocols for any of those calibrations, please just check out the WRE website, or give me a call or shoot me a text, and I can get those over to you. Even if you run your metrics in-house, do send a couple of samples once in a while to a service lab just to double check. So, again, we talked about how juice can be really unstable. You might want to send a couple of wine samples once in a while just to make sure that your pH meter is on par with the pH meter nearby at a service lab that has those calibrations in place. I would also say, and this is part of what came up for Rick, is, always compare to the values that you expect, either from your in-house numbers or from historic data. We had this happen a couple of years ago where we had some petite mensang fruit chemistry coming back with a pH of like 3.7 on fruit that wasn't even ripe. And we knew from historic data that that just wasn't something to expect at all. If you're getting numbers back that don't make sense to you, the first thing to do is to call your service lab and talk about it. Talk about whether that sample might have been compromised in transit. Talk about whether there might be differences based on freezing or not freezing. And sometimes if there is sort of an aberrant number, sometimes they'll go ahead and rerun that for you in case there was some human error happening at the lab. The service lab doesn't have the same context for what those numbers are that you do. So if something doesn't look right, have a dialogue with your service lab and see if you can figure out what might be happening there. And then lastly, always just be aware that we're sort of aiming at a range of values and not like there is some error inherent every time we take these tests. So if we go back to the Yan example, if you're somebody that wants to err on the side of having a nutrient desert at the end, maybe you would realize that I'm on the edge of the numbers here for whether I need to feed or not. So I'm going to decide not to feed. If you're somebody who really needs to have fermentation security and make sure you get dry on that particular fermentation, if you're close to the edge, go ahead and feed a little bit more in case the error is underreporting that value. Okay, so with all of that, Rick, what do you think? What's your plan for juice for this year?
Well, I'm going to do the same as I did last year, except for Yans, I've finally got a pH meter that I think I can be confident in my ability to run it. So we'll see how that goes. And then just the two sugar measures we do in-house and keep them compared to the lab, knowing that I will say, I got to interrupt myself, is that when you talk about we may or may not send frozen samples to a local lab, I think at least from our vantage or whatever, is that I send them all frozen for whites, especially because we're doing so many different whites over the course of, say, 2 weeks, that it's easier for me to freeze them, put them in the freezer, put them in a box, and then take them over than to send them one by one to the lab. So I think that I will take that part of it into consideration, knowing that it could have thawed out on their counter or something else. When I see the difference in Yans and bricks, that was pretty interesting to see. But so I will do it mostly for Yans. The one thing that I noticed and jotted down while we were talking is that most of the grapes that we get from our vineyard and vineyards we lease or buy from, we've bought from or used consistently for at least 3 or 4 or 5 years, most of them. So I have a baseline of laboratory analysis that I can go back and look at, which I think is what threw me off a little bit last year, because I know which vineyards are going to be less than 100 for Yan. And if it starts showing a number that's consistently different than that, I will say, well, maybe there's something a little bit odd about that, and hence the call to Dr. Ting. I will say that I will be paying a lot more attention to Yans from our vineyard and our leased vineyard this year, is because we started a semi-aggressive nutrition program. And if it doesn't show up in Yans, I'm going to start to wonder about how much of an effort that, whether or not it was really worth it or not. So yeah, that's one of my changes, that I'm going to try as much as I can to get a grip on doing the TA. I will tell you that may or may not work out, but I am fairly confident that my pH monitoring skills will be close to all right. And I'm going to get like you said, the box wine is a really good idea to put that in the sample, send that to a lab, so at least you have a consistent standard. And then, of course, you can discuss the other part about the pH dip method, because I'm running out of steam right now. So, yeah. With the standards, it's making sure that you're not cross-contaminating your standard when you're
yes,
your pH meter. one of my problems with measuring pH is not being sure that the standard itself is accurate after rinsing
Right.
off the electrode and then putting it in either the 4 point whatever 0.02 and the 7.02 standards. Is that if the standard is wrong, then your reading is already automatically wrong. And then once you lose confidence in your pH meter, I mean, not speaking from personal experience, you would probably stop doing it. So,
Yeah.
yeah, and
Right.
a
Yeah.
lot
So, I mean,
lab results. That's and so if all you're depending on a lab result, and this is showing that even though the labs are pretty consistent, there is some inconsistency that they're human too, is that they may not be right. So if you have an idea of, well, I did it this way, and I'm pretty sure I was right because I'm confident in the machine, then you have a much more information to make a decision with, especially with the yans. Those yan numbers are. I will my fermentation will be different because of a difference of 50 in yen or a difference of
yeah.
30 in yen if it's on the line.
Right.
So, yeah. So
Yeah,
that's
so
it.
I mean, I think you make a couple of really good points. Like just to like, if you're having to freeze your sample, the malic acid and the yan should stay the same. So if you're having to freeze a bunch of samples and send them, those are good samples to send for malic acid and for yan. But it is a matter of realizing though that that pH number and the TA number will most likely change because you're doing that essentially that cold stabilization. So having good in-house pH is a great addition. And as you said, like keeping the buffers good and clean. This was something Rick actually said to me last week, but just essentially having two buffer solutions. You have your main stock solution, and then you have actually two sort of subdivisions of that. One of them that you just dip the pH meter in to essentially rinse it off, and then you use the second one always with a sort of pre-dipped pH probe, so that you know that you're always getting a good clean sample of your pH buffer. And then again, that other thing of having those standards, either the box wine or the cream of tartar, also gives you an idea of whether you're doing that properly. Most pH meters will also give you some information on your calibration itself, how good the slope is, and how good your response time is. And a lot of times that can help you to understand if you've got a good calibration or not. So, okay, well, Rick, thank you so much for doing this. Thanks for playing along on our first 20-minute takeaway video. I think we're just at 20 minutes or very close. So
I have a 20-second question.
Okay.
If you're sampling reds, does it matter if you're sampling them right when they get in the bin, or if they've been in the bin for a day, a matter of either hours or days, and they haven't?
That is an excellent question. So we're going to have a quick bonus round because it will take me a minute to answer that one. But
okay.
What we've seen with reds is exactly what you expect with reds, is the longer it stays on skins, the more the skin components come off into the juice. So what that really does is you're taking more of the potassium from the skins into the juice. So you will see the pH go up the longer you do cold soak, for example. For folks that do cold soak, you'll see the pH go up. If you do have any microbial activity, there may be some yan that goes down if you have Hanseníaspora or low-level Saccharomyces or anything like that. You might have a little bit of yan drop. So if you are doing cold soak, the best thing to do there is to take your juice sample at the end of your cold soak, because that tells you what your yeast are actually going to be encountering, especially in regard to yan. So if there has been any microbial activity during cold soak, you want to know about that so that you can make sure your yeast have proper nutrition. That's a great question, Rick.
Oh, I'm writing stuff down, Joy. I'll tell you. All right.
Okay, as you write, I'm going to go ahead and wrap us up. So if anyone does have additional questions about any of these topics, about calibrating your pH meters, about when to take your samples, please feel free to send me an email, give me a call, shoot me a text, and I would be happy to talk about it further. So with this, we're going to go ahead and wrap up. But thank you all so much for listening in today. Thanks, Rick, for joining us. And we wish everybody a happy harvest.